Hello guys, today we're going to prove the power rule of calculus. As I said before, the best way to remember your mathematical theories, your mathematical formulas, your mathematical rules is by actually proving those rules, proving those formulas. This way it's going to be encrypted into your body. It's going to stay in your brain forever. Okay? So let's start with the power rule definition that says that if you have a function f of x that is equal to x to the n power, then the derivative of that function is going to be n times x to the n minus 1 power. All right? So let's put the definition, the limit definition of the derivative. So it says limit of h approaching to 0 of f of x plus h minus f of x over h, right? So basically it's saying that how the function is going to change when x is changing. So this is what we're trying to define. We're trying to find that, right? So it says when x is changing, how the function is going to change. That's why you have a difference there on top, right? So, but in this, the h approaching to 0 is because we're trying to find the change in the function when there is a microscopic change of the independent variable. Remember the x, usually the independent variable. How the independent variable change is going to affect the dependent variable. And that's something very powerful. We can use this in physics, in medicine, in biology, even right now with the coronavirus, we are using calculus because we're trying to define, how when you're moving one variable, how is going to be the final outcome, how is going to be the change in the final outcome. All right. So to prove that, we're going to use an identity that we learn in college algebra, mathematics 1, 2, all right, that says that if you have a n minus b to the n power, that is going to be equal to a minus b times, and pay attention to this, the a, right, is going to be decreasing the exponent. So we're going to start with a n minus 1. Why a n minus 1? Because if you multiply by a, you have to produce n, of course, right? So it has to reduce by 1 because I have already 1 here, a. So n, then remember, a is going to be decreasing, the exponent for a is going to be decreasing, and the exponent for b is going to be increasing. So we can start here with b to the 0 power, but b to the 0 power is 1, all right? So I'm not going to put that. But just remember, there is a b to the 0 power. So what will be the next exponent? The next exponent is going to be a to the n minus 2, right? Because the exponent for a has to be decreasing. Then I have b to the 0 power that I didn't write. Then the next exponent for b will be b to the 1, which I don't write 1, right? We don't write exponent 1. The next term will be, remember, we are reducing, right? So it will be a to the n minus 3. And now b is going to be increasing by 1. So that will be b squared. And we will continue this, but we know that the last term, as the first term was a to the n minus 1 power, the last term will be b to the n minus 1. And we cross the bracket there. All right? But anyway, this is something that, you learn in college algebra, but we're going to use this identity to prove the power rule. So let's replace the function here, right? So you have f of x plus h. Remember, whenever you see x here, you're going to replace it with x plus h. So that's going to be x plus h to the n minus f of x, which is x to the n, over h. All right, I just replace the functions with according to the definition of the function right there, the exponential function, right? X to the n. All right. So what you notice here, that you have difference of 2 n powers, right? You see a to the n minus b to the n. I have x plus h to the n minus x to the n. So I'm going to use that identity, right? I'm going to use that identity to expand these 2 powers, right? So I'm going to label this one is going to be my a, and this one's going to be my b. See? Because I want to compare with this, right? They look very alike. So, and then I'm going to follow that. The first term is going to be what? A minus b. So that will be a is x plus h. B is x. So right there I have a minus b. This is my a minus b, right? Because x plus h is a and x is b. Then I'm going to open the bracket here. We're going to do this monster right there, okay? It's not difficult. It's about just replacing, substituting expressions, all right? And then we're gonna reduce, okay? I promise it's going to be easy. So x plus h is a, right? Which is a to the n minus 1 power. So it will be x plus h to the n minus 1 power. Then plus a again, which is x plus h to the what? N minus 2 power, right? Multiply by b. Look, multiply by b. Which one is b? X. Multiply by x. Plus x plus h to the n minus 3 power times b squared, which is b is x squared, plus b, the last term is b is x, so that will be x to the n minus 1 power, cross bracket, over h. Remember, we're coming from here, right? We're coming from here, right? Remember, this is limit 2. I forgot to put a limit h, right? That's limit h to the 0, right? So now, let's cross this out. Let's simplify this algebra. X minus x, they cross it out. I'm going to have factor h here and h here, right? So we're going to cross this out too. And then remember that h is approaching to 0. So that means, since we are doing, something really tiny, we're going to assume that all is gone, right? H is gone, h is gone, h is gone too, right? Because as I'm saying, this is really close to 0. Something like, let's say 0.000000000. It's like you can put millions of zeros and then 1, all right? So that's why we're assuming that h is nothing, because it's almost nothing. All right. So then what we have, let's continue now. I have equals to x to the n minus 1, right? Here, because h is gone. The second term, x to the n minus 2 times x. Remember, this is exponent 1, right? So how much is negative 2 plus 1? Negative 2 plus 1 is negative 1. So that will be x to the n minus 1 again, right? So we did that one. So then we have n minus 3 plus 2. How much is negative 3 plus 2? Negative 3 plus 2 is negative 1. So that will be x n minus 1 again, right? Plus the last one is x n minus 1. Now the question is, how many terms do I have here, right? We don't know, but according to the identity, there are n terms here. There are n terms here. All right? That's the way we expand the identity, an to the minus bn. All right? So if you have a cubed minus b cubed, you will have a trinomial here. You will have three terms. A squared minus b squared, you will have what? a plus b, the famous a minus b times a plus b, right? Anyway, that's something for college algebra. Then it's just, you need to refresh this if you don't remember that. But just remember that you have n terms here. So therefore, here we're going to have n terms. All right, n terms. So let's multiply now. Let's multiply, So since I have n terms, I have n terms times x to the n minus 1, right? Because this is the number of terms that I have, n times x to the n minus 1, which is equal on this side, limit of h approaching to 0 of x plus h raised to n minus x to the n over h. But what's that? That is the derivative, because that was the definition of the derivative. F prime of x will be n times x to the n minus 1. All right? All right, so that's the proof of the power rule of calculus. All right? One more time, I'm going to put, there. So all the steps. First, we define the power rule. We put the limit definition of the derivative. We use the identity, right, that we learned in algebra. And we expanded this, we simplify, and then at the end, we got this simple expression, which is equal to the first power rule definition. All right? Thank you for watching. If you have any question, please let me know. Just want to give a shout out to my student, G. Gonzalez from Queens College. Bye, guys.